new out-of-this-world discovery has some asking, what in the world is this? Take a look. NASA scientists say it's a comet. That's what they say. They've named it the 3-1 Atlas interstellar object, which was discovered last month.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
An absolutely wild scientific moment is about to go down. The interstellar object, known as 3I Atlas, is putting on a cosmic show. It's grown a massive glowing ion tail as it swings closer to the sun. And get this, two spacecraft, Hera and Europa Clipper, are about to pass straight through the downwind region of that tail in the coming days. None of this was planned, yet it could become one of the most groundbreaking moments in modern astronomy. Imagine being able to collect the first ever direct samples from the tail of an interstellar comet. That's history in the making. In this video, we're breaking down how this insane opportunity just happened by accident, why scientists are losing their minds over it, and what might happen next. 3I Atlas is only the third confirmed interstellar visitor ever spotted, following the mysterious Oumuamua and the Comet 2, I Borisov. It was discovered earlier this year and has been getting brighter and brighter as it races toward its closest point to the Sun on October 29th. As sunlight heats it up, gases burst out of its frozen surface, creating a long, twisting trail of ions and water vapor blasted away by the powerful solar wind. Meanwhile, across our solar system, two legendary space missions are on their own journeys. Hera is heading toward the Didymos Dimorphos binary asteroid system to study the debris from NASA's wild DART impact test, while Europa Clipper is cruising toward Jupiter's icy moon Europa to find out if it could actually support life. But here's where things get jaw-dropping. By total cosmic coincidence, both spacecraft will cross right through the outskirts of 3I Atlas' enormous tail. Hera's observation window runs October 25th to November 1st, and Europa Clipper's from October 30th to November 6th. Using a tool called Tail Catcher, scientists modeled the direction of the solar wind and figured out that both spacecraft will pass about 8 million kilometers from the main axis of the tail. Not exactly close to the nucleus, but close enough to possibly touch the charged particles drifting through space. Hera doesn't carry instruments for magnetic or plasma detection, so it'll mostly track position and geometry to refine the encounter map. But Europa Clipper, that's the real MVP here. It's equipped with a magnetometer and plasma analyzers, perfect for detecting subtle shifts in magnetic fields and charged ions caused by the comet's collision with the solar wind. This cosmic coincidence won't last long. The tail itself could shift or break apart at any moment due to changing solar wind speeds. Scientists are racing to capture as much data as possible, while the universe lines everything up just right. Even so, this cosmic alignment is unbelievably rare, a once-in-a-lifetime chance to directly study an interstellar object using spacecraft that are already out there in space. It's pure astronomical luck. Scientists are fired up because this could finally open the door to understanding what kind of materials are born around other stars, the building blocks of entire alien worlds. Interstellar objects are like time capsules from other solar systems. Their chemical fingerprints and physical makeup hold secrets about the environments they came from, clues to how other planets and stars were formed. Until now, every single observation of these wanderers came only from telescopes on or near Earth. No spacecraft has ever gotten up close enough to sniff their particles or touch their tails, until now. If Europa Clipper manages to record readings from the ion tail of 3I Atlas, it would be historic, the first ever direct measurements from an interstellar comet. Even a tiny batch of data could rewrite what we think we know about the differences between comets from other star systems and those native to our own solar neighborhood. The scientific objectives are crystal clear. Researchers want to study the ion and plasma characteristics, things like how dense the tail is, how particles are distributed, and how much energy they carry. They also want to map the magnetic structure to see how the comet's material collides and dances with the solar wind, twisting magnetic field lines as it moves through space. And finally, a comparative analysis, figuring out whether these deep space visitors behave differently from the comets we've known for decades. This event could also help scientists test and upgrade theoretical models like Tailcatcher, which predicts how solar wind sculpts a comet's tail. The catch? No one's ever verified those predictions for an interstellar object before. So even a partial dataset, a few readings here and there, could completely transform how these models are built and used for future missions. Of course, there's a lot of uncertainty. The spacecraft will pass far from the tail's dense center, meaning the stream of charged particles could be faint or scattered. Plus, solar wind conditions can flip in hours, shifting the entire tail away from the expected path. And since neither Hera nor Europa Clipper was built with this exact mission in mind, scientists are rushing to reprogram instruments and prep for a short observation window. But here's the exciting part. Even if the data ends up fuzzy or limited, it still matters. Every reading, even a null result, tells scientists something about what's not there, helping tighten the models and future predictions. If Europa Clipper pulls this off and captures even a hint of charged particles from 3I Atlas, it'll mark a major milestone in interstellar exploration. For the first time ever, humanity would have direct evidence from the space surrounding an object that was born beyond our solar system. These readings could reshape how we understand cosmic winds, track the origins of wandering comets, and improve the way we model planetary system formation. It's also a bold reminder of how powerful adaptability can be, because neither Hera nor Europa Clipper was ever meant to chase alien visitors. Yet with a few smart tweaks, Europa Clipper might collect data that rewrites space science forever. This entire event shows just how incredible space exploration can be when missions adapt on the fly. Sometimes the universe throws a wild curveball, and if scientists can pivot fast enough, they can turn a surprise into a discovery. This kind of mid-course adaptation could become vital as we start spotting more interstellar visitors drifting through our solar system in the years ahead. The lessons learned here could totally shape the next generation of space missions. The European Space Agency's upcoming Comet Interceptor mission, for example, is being built with flexibility in mind. It's designed to chase and study pristine comets, or maybe even future interstellar objects, like 3I Atlas. Real-world data from Europa Clipper could influence everything from how instruments are tuned for sensitivity to how spacecraft navigate and operate during quick encounters like this one. But the clock is ticking. Time is brutally short. Hera's role will likely stay limited to tracking and positional reference, helping map the geometry of the event. Meanwhile, Europa Clipper's science team has to move fast to reconfigure its instruments in time for that tight encounter window. If they manage to pull it off, the spacecraft could capture once-in-a-lifetime readings straight from the outskirts of an interstellar comet's tail. Afterward, scientists will compare those readings to predictive models, checking how accurate our simulations of tail dynamics and solar wind behavior really are. And even if Europa Clipper ends up detecting nothing at all, that nothing still matters. A null result would reveal the limits of our sensors and give scientists crucial calibration data for future encounters. This entire situation is a reminder of how rare and thrilling cosmic coincidences can be. A totally unplanned alignment between missions and an interstellar traveler. It's the kind of thing that happens maybe once in a century. If Europa Clipper pulls this off, it could deliver the first ever direct measurements from 3I Atlas tail, a moment that could redefine how we study visitors from beyond the stars. Whatever happens, this will absolutely shape how future space missions approach interstellar objects with sharper tools, faster reactions, and bolder ambitions. Thanks for watching. Don't forget to like, subscribe, and stay tuned for more cosmic discoveries. See you in the next one.